Hello, thank you for watching this video. So on this video, I'll be doing question 8 of May, June 2024 question paper mathematics paper 1. The topic is calculus, I would say, or derivatives if you want to. So let's go. 8.1. Determine f prime of x from first principles if it is given that f of x is equal to 1 over x. So you're given that f of x is equal to 1 over x, right? So they wanted to find f prime and x, which is the derivative of f with respect to x. That's what they're looking for. So they have given you f of x to be equal to 1 over x. So they're saying now find the derivative of f, which is f prime and x. So find the derivative of f as a function of x, right? From first principles. What does it mean from first principles? So which means they want you to use the fundamental basics of the derivative, which means the definition of the derivative, right? So you know very well that the definition of a derivative, f prime as a function of x is equal to the limit as h goes to 0 of f and x plus h minus f and x all over h. So this is your derivative definition, right? So the derivative of f with respect to x is equal to the limit as h goes to 0 of this, right? No problem. So we should use this definition to find the derivative of f. So what do? I'll say the first thing that we should do, let's find this top part here. So let's find f of x plus h minus f of x. That's what we need to find. That is what we need to find, right? Fine. What is f of x? Actually, what is f of x? F of x was given that f of x is equal to 1 over x, right? No problem. So we found this part. What is f at x plus h? F at x plus h is equal to, so which means you want f at x plus h, right? So what you need to do, you need to substitute your f plus h on a function f and see what you get. So f at x plus h is equal to 1 over, you put your x plus h there, which is x plus h. So you get that f at x is this, f at x plus h is this. So let's find the difference between the two. So the difference is this. So f at x plus h minus f at x is equal to what? It's equal to 1 over x plus h minus 1 over x. This is what we have. Then what do? Then we simplify this, right? Fine. This time this, so it's all over x into x plus h, right? Then this times that, x, this time that, minus x plus h. That's what we have. Then from here, you simplify. So this is the same as f at x plus h minus f of x. So your f plus h minus f at x is equal to what? So it's equal to x, then we multiply the bracket out. Negative times x, so it's minus x. Negative times h is minus h. All over x into x plus h. Right? So this and that go away. So you get that your f at x plus h minus f of x is only equal to negative h, which is left there, all over x into x plus h. That's what you have. So you managed to find the difference between f at x plus h and f at x. So now you take what you have here, you go and substitute on your definition. So you have this difference here to be equal to that. So you substitute this difference here, which is negative x over x into x plus h. There. So then that's how you start finding now your derivative. So what do? So okay, f prime and x is equal to what? Is equal to the limit as h goes to 0 of what? Of f of x minus, of f at x plus h minus f at x, right? You have that difference to be what? It's equal to minus h all over x into x plus h. So what you see here is this. And this is that. This is all over what? All over h. That's what we have. Because look at it. F prime equal to the limit as h goes to 0, limit as h goes to 0 of this difference here. And you found that difference there. So this difference of yours, you substitute there and all divided by h, as you see here. Then what you do, just simplify. F prime at x is equal to the limit as h goes to 0 of negative h over x into x plus h, right? Which is this. This should be out here. This is h for the top one. Divided by h. So you change this division into a multiplication. So f prime at x is equal to the limit as h go to 0 of negative h over x into x plus h times. So this is over 1. So if you change this to a multiplication sign, it's equivalent to times 1 over h. So this h and that h go away. So you're left with f prime at x to be equal to the limit as h go to 0 of what? Of negative 1 over x into x plus h. So look now, the difference from this step and the step above, right? Here you couldn't allow h to go to 0 because h was a denominator, it was dividing here, right? So if you allow h to go to 0 and have 0, then have 0, what are you going to get if you divide by 0? Same thing here, you are still dividing by h, right? Same thing here, h is still a numerator, a denominator, sorry. So if h is 0, you are going to have problems, right? But now that we've got rid of a singular h as a denominator, or that alone h as a denominator, we can put 0 there with no fear of anything, because we won't have a situation where we're dividing by 0, right? So you can see here, if we can put h here, there will be no problem. You will be able to simplify that with no problem. So what do we do? What we do now, we'll just allow our h to go to 0. If our h goes to 0, our f prime at x is equal to what? It's going to be equal to minus 1. You don't write that anymore because we're allowing h to be 0 now. Which is we're going to put 0 there. Over x into x plus 0, which is equal to negative 1 over x squared. So that is the derivative of f with respect to x using the limit, using the derivative definition, using first principles. So here's the derivative of f with respect to x, and I hope it does make sense to you as it does to me. So I'll clean the board now, and then we'll go to 8.2. So let's clean the board. Okay, so now we're doing 8.2. 8.2 reads as follows. Determine the derivative with respect to x of the square root of 4 times x raised to 6 plus the square root of 2 times x squared. So they want us to find the derivative with respect to x of this thing here. Right? No problem. So let's look at these things that we have here. We have a slight challenge here because the variable that we want to derive with, or that we want to derive, is under this root. So we must first remove it under the square root here, right? This time we don't have any problem because the variable that we're interested in deriving is just sitting on its own there, right? Having a great life. So we don't have any problems here. So let's solve this part. So you know from your sets, when you're doing sets, that the square root of a, b, which is a times b, is equal to the square root of a times the square root of b, right? So what we have here is the square root of 4 times x raised 6. So which means we can use the same law that we know from the sets. So the derivative of this thing is equal to what? The derivative with respect to x of what? Of the square root of 4 times the square root of x raised 6 plus the square root of 2 times x raised 2, which is x squared. So we've expanded this, or we've used the side laws for this to this. So what we can do here, we can now try to simplify it. So this is equal to the derivative with respect to x still of what? Of square root of 4, what is it? It's 2 times square root of x raised 6. So you know very well, if you have the square root of a, or let's say the nth root of a raised m, this is equal to a, you divide the power of a by n. So what you have is m over n. These are your sets still, right? If you have the nth root of a raised m, whatever that you have there, you divide it by m if you wanted to write it in a power form. I don't know. So what you have here, you know, on the square root there's 2 here, there's 2 that you don't write. So what you have, you will have times x raised 6 over 2. That is the same law that I have there, plus the square root of 2 times x squared. So what do we do? Let's first simplify this to the simplest form. So this is equal to the derivative with respect to x of what is in here, which is 2. X, what is the answer to that? The answer to that is 3 plus square root of 2 times x squared. So what do we do at this point? We just derive at this point. The derivative of this is going to be 3 times 2, which is 2 times 3, which is from there. And then from that 3, we subtract a 1. Plus, it's going to be the root of 2 multiplied by that 2 up there. And from that 2 up there, we subtract a 1. So this is equal to what? This time this is 6x raised 2, because this is 2 plus 2 root 2 x. So this is the derivative of the first thing with respect to x. And we're done with it. So we'll move on to the next question, which is 8.2.2. That's where we're headed at this very moment. So let's go. They are saying that they have given you that g of x is defined by what? By 3 raised x, or 4 minus 4x squared plus 6, all divided by x squared. That's what they've given you. So at 8.2.1, they're saying determine g prime, which is the derivative of g with respect to x, if g of x is that. So they want us to find the derivative of g with respect to x. That's what they want us to find. So what do we do? So for your 11, which is the grade 12 11, you cannot derive if you have a variable as a denominator, right? So we should try to get this variable up there. That's what we should try to do. So what do? You can say, okay, g of x is equal to, I'm going to rewrite it, 3x to the power 4 minus 4x squared plus 6 all over x raised 2. So we allow this x squared to divide all of them separately. Or you can take it up here and multiply with x raised minus 2. That's what you can do. You can allow x squared to divide each one of them, or take it up there so that it multiplies everything up here. That's what you can try to do. But I'm not going to do that. I'll allow x squared to divide each one of them. So what do? Say g of x, we first simplify so that actually what I'm going to do, I'm going to take this up here so that it changes the exponent sign and multiply the rest of this thing with it. That's what I will do. So let's do that. Because we're trying to get rid of the numerator of a variable as a denominator. We're trying to get rid of that variable as a denominator. So we don't want x to be sitting down here. So this will be 3 to the power 4 minus 4x squared, right? plus 6. Take this to the top, which is times x raised negative 2. You know this very well from your exponents, right? So what do? Say your g of x is equal to what? This times that, so we have 3x to the power 4 times x to the power minus 2 minus 4x squared times x to the power minus 2 plus 6x to the power minus 2. So g prime, g of x, which is the simplification of this, is equal to 3x, the bases are the same of these x's. Take one base and add exponent. So going to be 4 plus minus 2 minus 4. The bases are the same. Take one base x and add the exponents, which is 2 plus minus 2 plus 6 raised negative 2. So g of x is equal to what? G of x is equal to 3x raised 2 minus 4x raised 0, which is 1, plus 6 x raised minus 2. Right? No problem. So from here we can derive, because we don't have a variable as a denominator. So your g prime and x is equal to what? 2 times 3, so it's going to be 2, which is that 2 up there, times 3. And then from x, from that 2, you minus 1. Minus 0 times 4, so you have 0 times 4, right? X raised 0 minus 1. Plus what? 6 times negative 2, which is this. And x raised negative 2. You subtract 1 there. Your final answer, g prime and x, is equal to this times this. This is 6x, right? Because this will be 1. 0 times 4 is 0. So this part is gone, because 0 times 4 is 0, right? 6 times negative 2 is minus 12. X raised negative 3. So, here is it. You can leave it here. It's okay. This is enough. But if you want to be extra, you can push it further. Let's try to be extra and see how that will go. So you have g prime and x to be equal to what? 6x minus 12. X raised minus 3. So your g prime and x is equal to 6x minus 12 over x cubed. So your g prime and x is equal to over 1, this time this, x all cubed, cross multiply, so 6x raised 4 minus 12 x minus 12, sorry, just ends like this. So I'll say this is the simplest form of this thing. So we're done with 8.2.2. Then we're going to move to 8.3. So I'll clean this board and we go to our 8.3. Okay, so the equation of a tangent to a function f is given by y is equal to 9x minus 9. Determine the values of a and b. Okay, let me read this thing again. The equation to a tangent to f of x given by 3x squared plus bx plus c at x is equal to 1 is given by y is equal to 9x minus 9. Determine the values of a and b. So, here's what we're told. We're told that y is equal to 9x minus 9 is a tangent to this function here. That's what we're told. We're told that y is equal to minus 9x minus 9, which is this line here, is a tangent to f of x. Right? That's what we're told. So, if we can try to draw a graph of it, I'll say, let's try to have a visual. These are the y-axis, which is the line x equal to 0. These are the x-axis, which is the line y is equal to 0, because y is 0 all this line, and x is 0 along that line. if you are looking at this, you can see that this function of yours, f of x, is positive. So I'll try to make it another color. It is positive. So I'll try to make it something like maybe this red function here that you can see. So I'll name this function f here. So it's passing me, these are the intercepts. I'm assuming that it does have intercepts. Maybe it doesn't, but I don't know. So we're told that a straight line with a positive gradient and the y-intercept at y is equal to -9. Let's say -9 is somewhere here. Is a tangent to this. So we have a straight line, maybe that is touching this function here. And the point of tangency or the point of contact is at x equal to 1. So this is 1 here, this point, this x value here. So we have a straight line like this. Let me make it another color. Let me use another color. Let me make the straight line not red. I'll use another color for the straight line so that it is clear. So straight line. Maybe the -9 is there now. Of course, this will not be beautiful. I'm trying to make a sense of what I'm given here. So the green function, I'm going to call it G, not G actually. Let me just call it Y here. This is your tangent. So the green function is your tangent. You can see it. So they are touching here at this point here. And the x value at that point is what? Is 1. There is it. That's what they are telling you. Okay. So they are telling you that the tangent is at x equal to 1. Right? So here is a tangent. So at this point where they are touching, these two functions have the same coordinates because they are touching exactly at the same point. Right? They are touching there. So they have exactly the same coordinates at x is equal to 1. Right? So what we want to find, since they told us f of x is given by this equation, so we have drawn a rough estimate of how this thing looks like. We know that y, which is the green function here, is a tangent to the red one at x is equal to 1. Right? Fine. And we're told that y is given by this equation. So what we can do is, since these two are touching at x equal to 1, we can find the full coordinates of y at x is equal to 1. So we can look at the green function y, and we know that it is x coordinate. Its x coordinate here at this point is x and y. So we have the coordinates for the green function there to be x and y, right? But we know the x coordinate is 1, so we can put 1 here. There is 1. But what are we missing? We're missing the y value. So we can use the equation of the green function to find the corresponding y value there. So let's go and do that. So I'm finding the coordinates of the green function, which is the tangent, where these two functions meet. So it's going to be y is equal to 9x minus 9. But x is 1, so y is equal to 9 times 1 minus 9. So your y is equal to 0. So the y value at this point, where these two meet, is 0. So they are meeting here, at this point here. That's what these two are meeting. Not meeting, they are touching at that point there. But I don't want to redraw this graph again. I'm going to leave it here. So take this point as if its coordinate is 1 and 0. It's not, but I don't want to redraw it. I'm not going to redraw this. It's going to be exactly the same logic. Fine. So we have the coordinates of y at the point where these two touch. It's 1 and 0. But both of them are sharing that same coordinate. Which means even on the red function, the coordinates, even on the red function, they should also be 1 and 0 because it's the same point that they're touching it. So it's 1 and 0 as well on the red function. Right? So what does it mean? This means that we have f of x, right, defined by 3x squared plus bx plus c to have the coordinates 1 and 0 on it. So the coordinates 1 and 0 lie on this function because they are there at the point of contact. at the point of tangency. So the green function, its coordinates, I found them to be 1 and 0. But since they are touching there, they have exactly the same coordinates, which means on the red function as well is 1 and 0. What does it mean here? It means if you substitute x here, which is 1 and 1 there, the answer that you should get should be 0. Because the same way we did this, look at it. I only had x to be 1, which I was given. So what I did, I took this x of mine, I substituted on this function here, and I got my y to be 0. I know now, since my coordinates are like this, if I substitute 1 here, I should get 0 there. The same logic you can use here. My y is 0 and my x is 1. Let's substitute that. So which means, if there is 0 here, which means I have to substitute 1 there. 3 into 1 squared plus b into 1 plus c. So 0 is equal to 3 plus b plus c. That is where we are. Now this is a problem. Because one the values of a, of b and c. But now we have two variables. So we cannot solve these equations with this b and c with one equation. Let's go and see if we can find another equation. That's what we need to do. So let's look at this thing. So I'm looking at it now. I know this is the incomplete equation of f here. This is the incomplete equation of f. So we're working with calculus derivatives, right? So a derivative f prime of a function gives what? It gives a gradient, right? At a point. F prime, a derivative of a function, gives you a gradient at a point, right? So let's find the derivative of this thing. If you derive that, you get that f prime at x is equal to what? 2 times 3, so you have 3 times 2, x on that x squared minus 1, plus b, because it would be 1 times whatever, so it's b. So f prime at x is equal to 6x plus b. So I said that a derivative of a function gives you a gradient at a point, right? So f prime at x gives us a gradient at point x, right? So listen now. I said f prime at x will give us the gradient at point x. If we substitute 1 here, if you find f prime at 1, put 1 there, put 1 there, you will get a gradient at x is equal to 1. But look, at this point here, you have a green function, and the green function have an equation, y is equal to 9x minus 9. You know the gradient of the green function at the point of contact. The gradient of the green function, which is a straight line, is equal to 9. So at that point, those two functions have exactly the same gradient, and their gradient is equal to what? Is equal to 9 to that point. This line here connects points which the gradient between them is equal to 9. That's what I can say. So at this point here, the gradient is equal to 9 on the green function on the straight line. So even on this one here, on the red one, the gradient should also be 9. Which means f prime at 1 should also equal to 9. So this is what I'm saying. Which means f prime at 1 should give us the gradient at x is equal to 1. Do you understand? Should I give us the gradient as x equal to, because I said f prime gives a gradient at a point. So f prime at x will give you the gradient at point x. So f prime at 1 should give you the gradient at x is equal to 1. And you know the green line have a gradient of 1 at x equal to 1. So even the red function should have the same gradient at that point. So which means you know that the gradient of f at x equal to 1 is equal to what? Is equal to 9. So f prime at 1, you substitute 1 there, you substitute 1 there. So which means it will be 6, because f of prime is equal to this. If you are saying f prime at 1, you put in 1 there. So f prime at 1 is equal to 6 times 1 plus b is equal to 9. Therefore, your B is equal to 3. Once you find your B, you can go back to this equation that had multiple variables, x, b, and c, and substitute your B, which is 3, and find your C. That's what we're going to do. We're going to say, okay, 0 is equal to what? Is equal to 3 plus B. What is B? The B is also 3 plus C. Therefore, your C is equal to minus 6. Therefore, your f prime or your f of x is equal to 3x squared plus 3x minus 6. So here's B, here's C, or here's B, here's C. And we're done with this question. We're done with it. We're done with this question. And I hope it does make sense to you as it does to me. Thank you for watching. Cheers.